Hello everyone, it's Benny, and today I'm back to the Designing a Minecraft Computer series. Except this time I'm doing a bit of a change in the series because the way I was doing it before, I was showing you how to design basically every single part of a computer from scratch. And while that would make you pretty outstanding at making Minecraft computers, it would also take the rest of my lifetime to complete it. So I'm going to be doing it a little bit differently. And to start this, I'm going to be teaching you the secret to making a Minecraft computer run at lightning fast speeds. So first off, I've built this sort of example computer to demonstrate this. So I'll just sort of walk you through it and demonstrate how everything is, so you'll at least understand what we're working with here. So, first off, we have our AOU. It's very simple. It's just an addition AOU. It only does addition, nothing else. Very simple. We have memory. It's not the same memory we used in the Building a Minecraft Computer tutorial series, but you've probably seen memory like this before. And in case you were wondering, the adder is the same adder we used in the... What's it called? Wow, I'm sorry, I'm having a total brain fart right now. But it's the one we used in the Minecraft calculator tutorial. Yes, that's it. This one's the exact same as the one I used in the Building a Minecraft Computer tutorial series. It's just a bit smaller. It's the same speed though. RAM, same story. It's the same speed, it's just a little bit... It's designed to fit vertically rather than horizontally. And registers, they're exactly the same as we used in the Building a Minecraft Computer tutorial series, so there's no change there. So the only real difference from a hardware standpoint between this and this sort of processing system than the one I used in the Building a Minecraft Computer tutorial series is that this one has half the RAM, which doesn't actually affect the speed, and the AOU does not have subtraction, which also will not have any effect on the speed. So, in terms of how it's going to run, this is going to run at exactly the same speed as the hardware that we built in the Building a Minecraft Computer tutorial series. So now we have sort of the program management section, has all the program commands. In terms of program commands, it's the same design as I used in the Building a Minecraft Computer tutorial series. The only difference is that I put the torches on the other direction when I programmed it, so that's the only real difference there. Clock, again, exact same thing as I used in the Building a Minecraft Computer tutorial series. The program sort of, what was it called? The sort of management system that determines which command is being read at a time, that's the only thing that I did differently than I did in the Building a Minecraft Computer tutorial series. Well, unless you want to count the RAM, but... Instead of using the system we did there, I instead opted to use a shift register, simply because it's a bit smaller. It's very marginally faster. It's, I believe, 1 tick faster. But yeah, it's mostly the exact same speed as the thing we used before. Except this time I don't explicitly have to state which command we're going to go to next, because I don't need to worry about that. I'm not going to be doing conditional branching or anything, so that doesn't actually matter. So that's really all the hardware. And now for the actual program, it's also pretty simple. It's 8 lines, but it's still pretty simple. What it does is, well, it will take whatever the output of the AOU is. So in this case, I have input 2 1s into the AOU just as a starting thing. So let's add those together and take a 2. It's going to take that. It's going to save that to the first RAM slot. And then it will read that out and save it as input A, then read that out again and save it as input B. So in this case it would get 2, so do 2 plus 2. And I would save that to the other RAM. And then it would take the new result, which would be a 4. Let's save that as input A. Take the old result and save that as input B. And then it would do the addition. So the end result of this was first it would take 1 plus 1, which would 2. That would give me an initial result. Then we'd do 2 plus 2, which is 4. Then we'd do 4 plus 2, which is 6. So very simple. So you might be wondering, well, what's so spectacular about this? This seems very simple, very basic. It's nothing spectacular. It's more or less the exact same thing you built in the Building a Minecraft Computer Tutorial series, except sort of simplified in some manner. And yeah, what's the point of this? The point actually lies in the clock. Now, if you remember, the very fastest we managed to get our clock to run in our Building a Minecraft Computer Tutorial series was... I forgot what the exact thing was in ticks, but in millihertz, the fastest we got was 384 millihertz. And that was around... I don't remember exactly, but it wasn't that fast. It was around... Oh, I'll just throw a shot in dark here. Just say a little bit under 10 ticks. So, not that fast. And I don't know, it's actually probably a little bit more than that. I don't really remember, in all honesty. But this one, if you look at our clock, 4 ticks. That's right, that's it. It's 4 ticks. This whole thing is running off of a 4-tick clock. And you might be expecting this to fail horrendously, but believe it or not, it works. It works completely. Everything works properly on a 4-tick clock. And in fact, to demonstrate this, I'm going to run it, and you'll see the commands going down the line very quickly. And then, at the end, if I turn this off, and I just load the first command again so that we can get rid of those torches, you'll see it came up with the appropriate result of 6. So yes, this whole thing runs on a 4-tick clock, believe it or not. So, let's just see if you can figure out how on earth this is possible, because I know there's at least a couple of people who are wondering how I could get the exact same hardware that I used in the Building Minecraft Computer Tutorial series, at least in terms of speed. I can get that exact hardware to suddenly run this fast. One of the obvious things I think a lot of people are probably going to say is, oh, well, your command lines in this one are really, really short. So that lack of delay is going to make it run a whole bunch faster. And well, no. The only thing that's going to change is the latency between the program command center and the actual processing unit. And that actually does not affect the speed of the computer at all. The delay between these two can be as long as you want it, and it will have absolutely no effect on the running speed of the computer. So that's actually not it. And that's why we could get away with having lines that had as much as 8 ticks of delay in the Building a Minecraft Computer Tutorial series, and still have a fairly decent rate of speed. It's also why when we decide to add conditional branching, that the speed suddenly went back down tremendously, and that's because all of a sudden that delay did matter, because the processing unit had to start talking back to the program command unit, rather than just the program command unit saying, okay, do this now, and do this now. So, yeah, the point being, that's not why it's run so much faster. Another thing you might be saying is, well, hey, your buses are a lot shorter here than they were in the Building a Minecraft Computer Tutorial series. Surely that's why it's running so much faster. And well, yes and no. Yes, that will add a little bit of speed to it, but it's not that much. If you think about it, our buses, even though they were longer in the one we built in the Building a Minecraft Computer Tutorial series, they weren't that much longer. They were maybe 1 tick longer, believe it or not, because these are still have 1-2 ticks right here. And I believe the buses in that series had 3 ticks. So the buses are actually pretty close to the same length in terms of delay. The writing bus, I think is actually the exact same speed. I believe it was 1 tick, maybe 2 in our Building Minecraft Computer Tutorial series. Here it's 1 tick. So it has potentially 1 tick gain, but again, 1 tick is not going to make that huge difference there. And so yeah, I think those are pretty much the 2 big things I'm going to hear in terms of why it's so much faster, even though it's not. Why it's so much faster? So yeah, that's not why it's so much faster. It's actually something completely different. It actually has to do with the way the program works. And no, I did not just literally sit down and program it to run faster, if that's what you're thinking. I did the exact same thing that real electrical engineers do when they're building real computers that allows our real computers to have clock rates that are in the several billion times per second. And I'll show you what that is. And it's a little hard to see, but it's pretty simple once you get your mind around it. So, in order to sort of understand this, you have to understand what the limiting factor on the clock rate is. And really, the limiting factor on the clock rate is it needs to allow enough time for whatever you're telling the computer to do for it to do that. So if you're telling it to read some information from memory, then the clock rate would have to be however long, as fast as it could possibly be, if that's all your computer had to do, was however long it was to read something from memory. If, say, you needed to read and write from memory, then whichever's the slowest of that, that's what the fastest your clock rate could be, because it needs to allow time for that. If you need to read, write, and add, it would be whichever the slowest of that is, and so forth, and so on. So, what was making our clock rate so slow in our Building Minecraft Computer tutorial series is we sort of amplified the limiting factor. Our limiting factor in that series was not just the amount of time it took to read from memory, or the amount of time it took to write from memory, or the amount of time it took to add. It was actually the amount of time it took to read from memory, write to memory, and to add. So it compounded all those delays. And the reason it compounded all those delays is because we set up the clock to allow time to do as many things as the programmer pleased in a single command. They could read something from memory, they could write something to memory, and they could do addition all in a single command. And while that's sort of great in a sense, it's also caused our computer to run a lot slower because every clock cycle needs to allow enough time for potentially all of those commands to run in the same cycle. And that will make your machine run really, really slow. So what you want to do is you want to separate them into sort of three categories of commands for each program command. You want to separate it into reading commands, so commands reading from memory, writing commands, so commands writing to memory, and ALU commands, which can be commanding the ALU to do anything that you want it to do. And those will be the sort of three different things that you divide the commands into. And if you divide the commands into groups like this will make your computer run a lot faster because the limiting factor on the clock rate will be whatever the slowest thing in the whole computer is. So in our case, it's actually the adder, because the adder takes 4 ticks to run through. So it's the fastest that you can get, unless you want to get into some weird design. There actually is a 3-tick adder out there, but it's a really weird design that's not easily done. So, for our purposes, the limiting factor is a 4-tick adder, and that's why our clock rate is 4 ticks. So, that's sort of the way that this works. Now, there is a bit of a problem with this design, and that is that every command can only do one sort of thing. It can either be reading from memory, it can be writing to memory, or it can be doing an ALU command. You can't be combining these things together, or it stops working. And this isn't that much of a problem. The only issue with this is you'll need a lot more program memory. So if you're from a design standpoint, you can't have a whole bunch of different program commands, then this may not be the right design for you. You may want to sacrifice a bit of speed for the computer in order to have the benefit of doing many things in a single command. But if you really want your computer to run fast, and I cannot stress enough how important it's going to be if you want a successful Minecraft computer, I cannot stress enough how important it's going to be to have your computer running as fast as you can possibly get it to run. If you want it to run as fast as you need it to run, you will want your commands laid out like this. Only one sort of group of command per line. Either a reading command, a writing command, or an ALU command. That's it. Nothing else. So, this is the first... That was the first in a quick series of all the different... I'm sorry. I am screwing this up horribly. This was the first in sort of my new way of doing the Designing a Minecraft Computer series. And this was about making our computer run as fast as possible. Because if we want to design an effective computer, we're going to need something that runs extremely fast. And really, 4 ticks on a computer that's just straight redstone, that's almost unheard of outside of instant wire and instant computing. So this is a really good start in terms of making computer run as fast as possible. And again, that's going to be necessary for making things later. So yeah, I hope you enjoyed, I hope you learned something. And yeah, I'll see you next time, where we will talk about conquering some other issues that will come up when designing your Minecraft computers. Thank you, see you next time.